All right, so our lesson today is on exponential functions, growth and decay. So our essential question is, how can I write and evaluate exponential expressions?
And who uses this? Well, if you're going to be a collector, collectors can use exponential functions to model the value of rare musical instruments. Pretty cool, huh?
Yeah.
Well, there's such a law. It's called Moore's Law. And so,
That one.
yeah, it's a rule used in the computer industry, actually, that states that the number of transistors per integrated circuit doubles. The key word here, that's why I wanted to read that, double. So when growth doubles, it can be modeled using an exponential function, and that's the kind of function we're going to talk about today.
Okay.
And the formula is what Miss Boyd highlighted, and the key here is to note that b is the base and x is the exponent. Now the important thing also is b is always going to be greater than 0. That means it cannot be negative. And b can never equal 1.
So a number greater than 0 can't be 1 and will never be negative.
Exactly. All right, so that is it for that page. So let's go to the next page. And we're here. Let's talk quickly about the word asymptote and the graph that is on this page.
Yeah.
And so notice another important thing to talk about is domain and range. And if we look at that graph, our domain is going to be all real numbers because the graph is going up and to the right forever. And it's going down and kind of evening out, but going to the left.
Never goes to 0.
No.
It will always go to the left.
So that's all real numbers. The y value, which is the range, notice it's never crossing the x-axis or going below.
So it's never
So the
negative.
range is going to be y greater than 0. And if you look up in that first paragraph, Miss Boyd, if you could highlight the domain is all real numbers right above you. Do you see that?
Yep, there we go.
So the domain is all real numbers, like I just said, and the range is y greater than 0 because the graph does not cross over the x-axis.
Okay.
All right. So now I'm getting to the term, asymptote. It's a line. And what it represents is this. As x in this case gets very large or very small. So in this case, your x value is getting smaller and smaller. It's going to the left and going to the left and going to the left. It's approaching what? It's approaching, it's approaching a horizontal line, y equals 0.
Okay.
So when your x value either gets very large or very small, it depends on the graph, the line that it approaches is called an asymptote. And values, an asymptote, it's not graphed here. Well, it kind of is graphed. Do you see the green? Do you see the green dashed? Yep. It's dashed because any values on an asymptote are undefined.
Okay.
So it's a line approached but never reached.
Okay.
That's the term for asymptote. Now here we go. We're going to talk today about exponential growth and exponential decay.
Okay.
And we're going to give you an example. If your b or your base is greater than 1, it is growth. Common sense.
Yeah.
Bigger than 1.
Getting bigger, growing. Okay, growth.
And if it's in between, it's greater than 0, because remember it can't be less than 0, but it's less than 1.
Like, for example, maybe like 0.5.
Yeah. That is considered exponential decay.
So it's less than 1, it's going lower, it's decaying, it's breaking down. Got it.
Now I throw this little remember in there just to refresh your memory that if you ever have a negative exponent, remember you're going to want to make it positive, and so you have to take the reciprocal.
Okay.
All right, there we go. Next page. I think we're ready for an example.
Okay.
Number 1, tell whether the function shows growth or decay.
Okay.
Then a graph. Well, we already graphed it for you.
This was our A,
yes.
and this is our B, right?
Right.
Okay.
So that's where students mess up. The B is always attached to the X, which is the exponent.
Okay.
So let's write B equals, and let's write what it's equal, because that's step 1. Right.
That's less than 1.
Exactly. And if it's
So
less
I'm
than
gonna say
1,
it's a Decay.
And that's exactly what you're going to write.
Perfect.
Okay, is decay. And graphing the function, we did that for you. So notice, in this
So
case,
Miss Young, do you normally just plug it in your calculator then?
yes,
Okay.
that's it.
Perfect.
Plug it into your calculator.
Oh, haha, if I would have read.
Yeah,
Plug it in your
yeah.
calculator.
And notice, in this one, as x is getting bigger and bigger and bigger, y is approaching,
0.
right, exactly.
But this time it's going this way.
Right, so the asymptote is again at y equals 0, which
Okay.
happens a lot. But
Mhm.
can you have an asymptote at y equals 1 or y equals -1? Sure,
Mhm.
but in this case, it's at y equals 0.
Okay.
Should we go on to number
Sure.
2? Okay, let's do that.
So it says find the base.
Mm-hmm.
So this is my A.
Yep.
This is my B.
Right,
It's bigger than 1.
right. So we should write b
Yep,
equals
B equals
1.2.
Bigger than 1, so it's a growth.
Yeah,
Awesome.
and again,
Oh, and
there's
that's
the
it.
graph.
We graphed it.
So again, this time, as x is getting smaller and smaller and smaller, it's
getting
approaching the
closer to
line
0.
y equals 0, which is the asymptote.
Okay.
Okay, let's see what we have next. Oh, we have another page. Oh boy, here we go.
Oh.
On to something new.
Okay.
Okay, you're going to want to memorize that formula that's in front of you right now.
Okay. Super important.
Right. It says you can model growth or decay by a constant percent increase or decrease with the following formula.
Okay.
And in this formula, R, as you can see, represents the rate of increase. A is the initial amount, the little
That
a,
one.
little
Got
a.
it. Got it.
And T represents the number of time periods.
Okay. So I'm just gonna say, this just came to me.
Yeah.
A is at the beginning of the
Yeah,
alphabet, so it's the
right.
initial amount. And it starts with A.
Exactly.
So beginning, initial. The first
And now,
one. Okay.
you know, it says rate of increase, which
But it
is
really
kind
should
of,
just be rate.
right, because if you're doing a depreciation, it's going to be 1 minus R,
Minus.
which is a decrease, okay? In this example that we're going to do, it's
Right.
representing an increase.
Okay.
R is, I'm going to tell you
Just
right
the
now,
rate.
is a percent,
Oh.
okay?
Always a percent.
R is going to be a percent.
Okay.
Typically, that's what it's going to be listed as.
Sweet.
In the formula, look at this. The base of the exponential expression, 1 plus r, that is the growth factor. And if it's 1 minus r, that is decay.
That makes sense.
Yes.
We're adding, so it's growth.
Right,
We're subtracting, it's decay.
exactly.
So you're not using both like when we did square root, we did plus and
Mm-mm.
minus.
No.
This one you're just picking which one based on if it's a growth or a decay.
Exactly.
Okay.
So example 3 says, Clara invests $5,000 in an account that pays 6.25% interest per year. After how many years will her investment be worth $10,000?
Okay. So this is our A. This is our initial investment.
Right.
Our initial amount.
Mm-hmm.
Like Miss Young said, percent is always going to be your rate. So that's your R.
However, what
Okay.
I'm going to have them do the minute
You want to change
you're
it
going
to
to,
decimal.
yes, that's what I wanted to
That's what I
say.
thought.
Mm-hmm.
All right, so I'm going to just kind of do this.
And maybe, yeah, well,
We
right,
got to move this 2 decimal spots.
right. And
So
so,
we add a 0.
right,
it's
so we can
really
write R down below next to it, or there, wherever.
0, 6, 2, 5.
Right,
That's
that
our
is your
R.
R. So you might want to write, see where you have this,
Mhm.
percent that we're going to change to a decimal.
Okay. I'm actually going to erase that percent. I
Yeah,
don't like it.
just,
Sorry.
yeah,
Percent, whatever.
that's fine.
Change to decimal. And you
Yeah.
might say there's already a decimal in there. That's okay.
What I might, you
There's
know
a
what you might want to
percent
do?
right there, so
Say,
we wanna
you know,
change
you
it.
might want to write percent, then change, because otherwise they
Oh,
might interpret
okay.
that as percent change to decimal. See what I'm
Gotcha.
saying? Yeah.
Percent.
Then
change.
yeah, to decimal.
Okay.
Okay? So I'm going to scroll
Yes, please.
down a little bit here for us.
Now we're just plugging in our formula.
Right. Write a function to model the growth in value of her investment. So what are we solving for?
We're solving for time. It says
Right.
how many years.
How many years?
So that's time.
Right. So let's
So we're
plug
solving
in
for this.
what we know.
All right.
We know f of t, that is our
That's
final
10,000.
amount, which is 10,000. So let's plug that in.
Our initial amount was 5,000.
Right.
They were nice enough and already gave us our equation.
Right.
Because it's a growth, they picked the plus.
Mm-hmm.
And then our rate we changed to
Mm.
0.0625.
Mm-hmm.
to the T.
Right. Now, I'm going to have you do, I just thought of one thing. I
Mhm.
apologize.
That's okay.
Can you erase the 10,000 for me for just a minute?
Sure.
Because I really didn't read the directions right. I'm
Oh.
jumping to step 2 before I even do step 1.
Okay.
Step 1, if I read it, but I really didn't do a good job of explaining it. It's asking for a function. So we
Oh.
need to leave it as f of t. Write
Gotcha.
a function to model the growth and value of her investment.
Okay.
So now, what is 1 plus 0.0625?
1.0625.
And we raise it to the power of
T.
t, and the 5,000 is out in front. And there we go. That is equal to, yes, exactly.
Okay.
Now, what I think we're going to have to do, Miss Boyd,
Is
hate
use
to
our
tell you this,
calculator.
step
Okay.
2, we're going to have to help them in class.
Okay.
Because it's asking us to use the graph to
So-
predict.
Yeah, so what we would do is we would plug this in our calculator under the
Mhm.
y equals
Yeah.
and go and see where the y value is 10,000
Yep,
to predict it. Okay,
Yep,
so we're gonna have to
exactly.
run the
I think, don't you think that's
Yep,
better?
I agree.
So we're going to finish that. Step 2, we will finish in class.
Mhm.
So now, if I go to the next page, we
just gonna
decided
skip
that
it.
we're going to skip
Yep.
this and do it in class.
Yeah,
And we're going to go on to the video questions.
perfect.
So find the value of the base, pretty straightforward, and then determine whether it shows growth or decay.
Mhm.
And number 2, tell whether the function shows growth or decay.
So those are
Pretty
super
darn
easy.
easy.
No guessing, actually try.
Read the
Thanks.
questions. Bye.
Bye.